Okay, welcome back. And now what we're going to do is we're going to look at concavity of this function. Okay, so the first thing we're going to do is we need to find the second derivative. So let's do the first derivative. So the first derivative will be 3x squared minus 12x plus 9. And then the second derivative is going to be 6x plus 12. Okay? So now, if the function changes concavity, it's going to occur when the second derivative is 0 or undefined. Now, since this is a polynomial function here, there's not going to be any places where it's going to be undefined, but we can set this equal to 0, and we find that x equals 2 is going to be the location of an inflection point. Okay, now, so let's see here. So now, if it's going to change concavity, it's going to change concavity at this critical point. Okay? So let's check. So this will split up the domain, which is all real numbers, into two intervals. So we're going to go from negative infinity to 2, and then from 2 to positive infinity. And so what we're going to do is we're going to check a test point, right? We're going to choose a test point in each one. Okay, so well, let's just try 3 here, and, oh no, let's do 0 here, sorry. Let's do 0 here, and 3 here. Well, if we plug in 0, we get a negative, right? So if we plug in 0, we find f prime of 0 is less than 0. F double prime of 3, well, that's going to give us a positive number. So that's going to be greater than 0. So guess what? So it goes from negative to positive concavity. So it goes from concave down to concave up when you pass through x equal to 2. Okay? So what does that tell us? Well, since this function is double differentiable, right? So you could get the second derivative. This is differentiable here, so this is a continuous function. And so guess what? Since it goes from concave down to concave up, it must have an inflection point at x equals 2. So therefore, that's our conclusion. So x equals 2 is the inflection point. So the inflection point is actually, I'm sorry, not x equals 2, but the inflection point is going to be at 2 comma, well, this is going to be 8, right, yeah. Let's do this. 8, and then 24, and 18 and 30. Okay, so we're going to have 26 minus 24, which is 2, so 32. So there's going to be an inflection point at 2 comma 32. That's it. And then of course you could graph this thing on your graphing calculator to confirm that you do have the correct answer. Have a great day.